Continue working on your scene from the last movie. If you need to catch up, open the scene file named flexarrowhead.max. You need to create the arrow that follows the path and that seemingly creates the water surface ripples. To create the arrow, start by creating a box in the top view. Make it about 0.05 meters in length, 0.6 meters in width, and 0.015 meters in height. You can fine-tune these adjustments later. In the Hierarchy panel, go into Effect Pivot Only mode and center the pivot to the object. Exit this mode when done and go back to the Modify panel. The box has only 6 polygons at this time. In order for it to deform while following the path, you need more subdivisions. Set the length segments to 3 and the width segments to 50. Rename the box Arrow and change its wire color if you need to. The box doesn't look much like an arrow just yet, but you'll get to taper it in a moment. First, to have the box follow the path and deform along the way, add a Path Deform WSM modifier to it. Choose Pick Path, and then point and select the path you adjusted earlier. Next, click the Move to Path button to move the box to the beginning of the path. You also need to specify a deformation axis, which is X in this case, to align the box to the path. From this point forward, you can animate the percent value to get the box to deform across the path. Now you need to taper the box to be shaped more like an arrowhead. Apply a taper modifier to the box. As the Path Deform binding is a WSM, World Space Modifier, the taper is located below it. Set the primary taper axis to X and the value to about minus 1.85. The box now looks more like an arrow. You can rework its basic parameters at any time. Try a length of 0.025 meters, a width of 0.8 meters, and a height of 0.007 meters. As always, feel free to experiment. You may also want to add more subdivisions, especially along the width, so that the box conforms to the path as much as possible. Mind you, the animated bounces are fast, as all 4 bounces happen in under 3 seconds. This means you will hardly have time to see any artifacts on the arrow mesh. Settle for 60 divisions for now. Next, you animate the Path Deform binding. Reset its percent value to 0 so that the box relocates to the beginning of the path. Before you animate the arrow, you need to extend the animation length a bit so that the ripples have some time to settle. Go to the Time Configuration dialog and set the animation length to 150 frames. That's about 5 seconds using an NTSC signal. Click OK to accept the changes and dismiss the dialog. Make sure the arrow is selected and enable Auto Key mode. Go to frame 80 and animate the percent value to go to 100. Exit Auto Key mode and then scrub your animation. The arrow is animated to follow and deform along the path for the first 80 frames or a little less than 3 seconds of animation. The arrow is a complex object now. It also has a lot of vertices to ensure it deforms nicely along the path. This prevents it from being an optimized object to use to create the ripples, as it will take a long time to process. Instead, you will use a much simpler object to drive the ripples, only you will make it non-renderable to prevent it from being displayed in the final output. Create a simple sphere in the top view. Name it Stone, as in a game of stone skipping. Make its radius about 0.03 meters and its number of segments 12. With the sphere selected, choose Animation, Constraints, Path Constraint, and point to the path. The sphere is now animated to follow the same path between frames 0 and 150. relocate frame 150 to 80 to match the arrow travel time. Expand the front view using Alt-W and press F3 to see the objects in shaded mode. If you need to, change their wire colors to differentiate them. Scrub the animation. The two objects, the arrow and the sphere, are not perfectly in sync. There are a couple of reasons for that. The most important is because the two animations are interpolated differently. Select the sphere and use the quad menu to go to the curve editor. Note the straight line, indicating a constant travel speed. Now select the arrow and expand Space Warp's Path Deform Binding. The curve shows acceleration and deceleration. Path Constraint defaults to a linear interpolation, whereas Path Deformation works in Bezier mode. In order to sync the two objects, you will use linear interpolation on both. Select the two keys that make the Path Deform Binding curve and set them to linear tangents. Now the two objects travel in sync, but the sphere needs to be relocated to the arrowhead. Select the sphere and take a look at its curve. The first keyframe, at frame 0, shows a value of 0, which indicates the beginning of the path. Keep the key at frame 0, but change that value so that it relocates to the arrowhead. In this case, a value of about 16 should work fine. Now scrub the animation until the arrowhead seems to reach the end of the path. This should be around frame 67. This is when the sphere should reach the end of the path, so that it stays with the arrowhead. At this time, the sphere reaches the end of the path, or 100%, at frame 80. Simply change that frame value so that the end of the path 100% value is reached earlier, in this case, on frame 67. Scrub the animation. The two objects are now perfectly in sync. Close the curve editor and reset the front view to wireframe mode, F3. Before you move to the next movie, make sure the sphere is selected, right-click and access its properties. Disable Renderable to prevent the sphere from appearing at render time. Save your file and move to the next movie to learn how to animate the ripples.